Let's imagine a future scenario where mobile phones, tablets, and other connected devices don't need those pesky SIM cards. A subscriber identity module, or SIM, is a small circuit board that securely stores the International Mobile Subscriber Identity, IMSI, and the related key used to identify and authenticate subscribers on mobile devices. Since the very purpose of a SIM card is for securely identifying the device, why can't software do what SIM cards do? Why does it have to be a physical piece of plastic and circuitry? In our future scenario, it's very easy to imagine these little plastic SIM cards becoming a thing of the past. What could legitimately replace their function? The answer is Bitcoin. SIM cards come with cost to manufacture, deliver from the factory to the carriers, including the labour of encoding carrier information, and then final delivery to the customer. All of this is unnecessary wastage. Any new technology that can save businesses operating and manufacturing costs, as well as billing overheads, would be adopted rapidly. In our future scenario, all cell phone networks actively monitor the Bitcoin blockchain. What for? In the present, each time you turn on your phone, it broadcasts a signal containing the International Mobile Subscriber Identity. That identification number links your device to your account with the carrier. In our Bitcoin world, the International Mobile Subscriber Identity is a public key such as a Bitcoin address. Your phone generates this public key from the private key that is stored securely on your phone. The carrier or anyone else listening to your phone's broadcasts will never know your private key because it never is broadcast. In fact, for added privacy, the public key will change frequently. However, the carrier can continue to identify your phone through the method of what's known as multi-signature verification. When you create an account with your carrier, they will generate a multi-signature address that both your phone and the carrier can sign, creating a secure relationship between the two parties. Each time your phone reconnects to the mobile network, it will sign a message sent to the multi-signature address, thereby informing the carrier of your new public key. The carrier knows that only your phone can sign to that address, and so your phone is on the network. Now, of course, the customer does not need to know anything about the keys or how the system works. This is merely a technical example of how the system would work to identify the phone to the network. However, on top of this secure identification, your phone would also be able to pay bills and buy apps using your Bitcoin wallet, which you can easily top up at any time by sending funds to the multi-signature address. Due to the divisible nature of Bitcoin, this gives carriers the ability to charge in real time for data usage by the kilobyte and voice calls by the second, without incurring transaction fees. You will know exactly how much credit you still have left, and billing will be fair and simple to understand. So the elimination of SIM cards would not only save carriers the cost of manufacture and programming, it would also save device makers such as Apple and Samsung the effort of designing a SIM card tray and all the internal hardware that goes along with it. For the consumer, carrier billing will be simpler and fairer thanks to the Bitcoin network, and perhaps devices will be thinner and cost less to manufacture.